Hi friends, welcome to Chemistry All in One. So today we are going to discuss about VSEPR theory, or basically we can say we'll be discussing the geometry of a molecule, how to find the geometry of a molecule, okay, from the given formula. That's it. Okay. So we know that VSEPR theory is based on, it's a repulsion theory, right? So it is based on electron pair repulsion. Electron pairs means both the bond pairs and the lone pairs. Okay. First, let me show you what are bond pairs and the lone pairs. Okay. So I'm writing an example, that is NH3, which is ammonia. Okay. So we can draw this structure based on the Lewis dot structure theory, right? So here we can see there is two electrons that is shared between nitrogen and hydrogen. Such electron pairs which is shared between two atoms are called bond pairs. Okay, so this is bond pair, bond pair, bond pair. There is three bond pairs in the ammonia. And now we can see two electrons which is not at all shared, and that unshared electron pairs is called lone pairs. So these are bond pairs and the unshared bonds are electron pairs are lone pairs, right? So that's it. Now, what is the VSEPR theory? Discuss itself. Okay. So the shape of a molecule depends upon the number of valential electron pairs, which means both bond pairs and lone pairs. Okay, both bond pairs and lone pairs. And we know that electron itself a negatively charged species, so the bond pairs and electron pairs will be repelling each other, and that leads to the geometry of the molecule. That's it. And one more thing that we have to note very carefully while dealing with the VSEPR theory is a multiple bond treated itself as a super electron pair or a single electron pair, which means if there is a structure in which there is multiple bond like this, we don't take this as a two different electron pairs. We know that there is two electron pairs are shared between carbon and oxygen, but still these electron pairs are treated as a single electron pair or super pair. Okay, so note it very well that multiple bonds are taken as single electron pair in the VSEPR theory. Okay, so VSEPR theory help us to decide the geometry, but the very basic thing that you have to know is the number of bond pairs and lone pairs. That is the main thing that will be teaching in this session. Okay, that's it. So if we know the, let's say we know that number of bond pairs and lone pairs, I'll be teaching you with examples. Okay, that's it. But before that, we have to know, if we know the bond pairs and lone pairs, number of bond pairs and lone pairs, how to find the geometry of a molecule. Okay, that is very simple. You just have to remember the table that is given in our NCERT. Okay, which is, I'm showing you. Okay, so let's say, so first let's discuss examples having or compounds having only bond pairs. There is no lone pairs in that molecule. In that case, what will be the structure? Okay, so let's say this is number of bond pairs only. Number of bond pairs only. If there is two bond pairs only in your molecule, then your structure will be linear. Okay, there is only bond pairs. And if there are three bond pairs, then it will be trigonal planar, 4 tetrahedral, 5 trigonal bipyramidal, 6 octahedral. Okay, this chart you have to remember. Okay, and now let's see some examples in which both the bond pairs and lone pairs are present. In that case, see, this is number of bonding electron pairs, number of lone pairs, and see here we can see a AB2E type, AB2E type, which simply the NCERT means B means, A means central atom, B means bond pairs, okay, E means lone pairs. Okay, that's it. So AB2, 2 means 2 bond pairs, 1, E means 1 lone pair, and so on. If there is two bond pairs and one lone pair, the structure will be bend shape. And if there is 3 and 1, that will be trigonal pyramidal. 2 and 2, bend shape. 4 and 1, seesaw shape. And we know that this is something very important, seesaw shape, that is the one which is frequently asked in our examinations, right? The seesaw structured compounds and the T-shaped compounds. Okay, next is the T-shaped one. The 3 bond pairs and 2 lone pairs will be the T-shaped geometry. If there is 5 bond pairs and 1 lone pair, that will be square pyramidal. If there are 4 bond pairs and 2 lone pair, that will be square planar. We'll be discussing some examples how to find the bond pairs and lone pairs. That is the main thing. Okay, I will be teaching you that. Okay, and if there are 3 bond pairs and 1 lone pair, that will be trigonal pyramidal. 2 bond pairs and 2 lone pair, which is bend shape. 4 bond pairs and 1 lone pair, that will be seesaw shape. Okay, so now let's see how to find the number of bond pairs and lone pairs based on the compound that is given. Okay, let's start with the BF3. Okay, here the boron is our central atom. So there may be a question how to find our central atom. Okay, that is very simple. You just have to look at the structure, and the one which having very least electronegativity will be our central atom, or the one which is less in number also can be considered as a central atom. But the best way to find the central atom is the one with least electronegativity. And one more thing, the hydrogen and fluorine will be never come as a central atom. Okay, noted well, hydrogen and fluorine. Okay, so now we know that boron is our central atom, and this boron has 3 valence electrons in its outer shell, right? So out of these 3 valence electrons, are shared with each fluorine. So will be this, right? So 3 electrons of boron shared with the 3 fluorine. So which means there is 3 bond pairs. That's it, 3 bond pairs. So now there is no electrons left in the valence shell of boron, which means 0 lone pairs. So out of the table, from the table we know that there is 3 bond pairs and no lone pairs. Then the shape will be trigonal planar. That's it, trigonal planar. So now let's discuss another example, that is CH4. Again, central atom will be carbon. If the central atom is carbon, which means it has 4 valence electrons, and these 4 valence electrons are shared with the monovalent hydrogens. Okay, monovalent hydrogen. So we have to know what are monovalent atoms and divalent atoms. Monovalent atoms are those which can make only single bond with the central atom, and the divalent atoms can make double bond with the central atom. So now there are 4 bond pairs now. So there are 4 bond pairs we can count and 0 lone pair. Based on the table, you can say now this is tetrahedral. Okay, now let's discuss examples having lone pairs. Okay, say ClF3. We know the central atom is chlorine, which means because it has a least electronegativity than the fluorine. If the central atom is chlorine, there will be 7 valence electrons. I'm simply drawing 7 valence electrons here. Okay, so each electrons are shared with 3 electrons are shared with the fluorine. So that will make 3 bond pairs. Now there are 2 lone pairs left. So now this structures means 3 bond pairs plus 2 lone pairs. Okay, so based on the table, you can say that 3 bond pairs and lone pairs means T-shape. Okay, T-shape. So let's take another example, that is SF4. SF4, so the sulfur will be the central atom. Sulfur has 6 valence electrons in the outermost shell. Out of this 6, 4 are shared with fluorine, which means there are 4 bond pairs, and 2 electrons left. 2 electrons left means 1 lone pair and 4 bond pairs. So if there are 4 bond pairs and 1 lone pair, the structure will be, we know that the structure will be seesaw shape. That's it. Okay, so now this is easy. Let's take another example, that is CO3 2 minus, a compound having negative charge. Now central atom is carbon, so 4 valence electrons. Okay, and there is negative charge which is 2. That means 2 electrons are extra gained by the carbon. So I'm taking 2 another electrons here. So, and one more thing you should know, that the oxygen is not a monovalent atom, but it is a divalent atom, which means the oxygen will be making double bonds with the carbon. Okay, look, this is not the exact structure I'm discussing. This is just a trick. Okay, I'm just saying that there is 3 bond pairs. I'm not saying that there is 3 double bonds between carbon and oxygen. That's just a trick. Okay, you cannot see 3 double bonds in the Lewis dot structure of carbonate. Okay, so this is a simple trick that can help us with the geometry. Okay, so now we can see 3 bond pairs. If there is 3 bond pairs, that means the given structure will be based on the 3 bond pairs. We can say the structure will be trigonal planar, because there is no lone. So let's do another example, that is SO4 2 minus, sulfate. Here the central atom is sulfur. There will be 6 valence electrons. And since there is negative charge, that is 2, we can add 2 more electrons. Okay, and we know that oxygen is a divalent atom. Divalent oxygen will be making double bond with the sulfur. Already told you that this is not the exact number of double bonds in its Lewis dot structure. This is just a trick that can help us with the geometry. That's it. Okay, you can count there is double bond, but which is not actually there. Okay, that's it. So double bond is taken as a single bond pair, or simply we can say there will be 4 bond pairs. Okay, single bond pairs only, and this 4 bond pairs means the structure will be tetrahedral. Another example, let's say BrF5. Central atom is bromine. So bromine has 7 valence electrons. So out of this 7, 5 are shared with fluorine. And after that sharing, there are 5 bond pairs and 1 lone pair. Okay, 5 bond pairs and 1 lone pair, which means the structure will be square pyramidal. Okay, square pyramidal. So let's take another example, that is SF6. Central atom is sulfur, 6 valence electron we can say, and out of these 6 electrons, all the 6 electrons are shared with the fluorine. So which means there is no lone pairs left. So 6 bond pairs will be there. 6 bond pairs means the structure will be octahedral. So that's it. Okay, now you can usually do these things it's yourself. Okay, I'm just gave you simple examples. Okay, so all about finding the number of bond pairs and lone pairs. After knowing the number of bond pairs and lone pairs, you're having this type of table in your NCERT that can help you with the geometry. That's it.